The discovery that could change everything expanded. One of the most brilliant and forward-thinking physicists of our time, Dr. Michio Kaku, has recently shared his thoughts on an astonishing discovery that could drastically alter our understanding of the universe and its origins. This groundbreaking revelation comes from none other than NASA's James Webb Space Telescope, JWST, a revolutionary observatory that was launched with the mission of exploring the deepest corners of the cosmos and unraveling the secrets of our early universe. What it has revealed goes far beyond what scientists had imagined. Dr. Kaku, globally recognized for his pioneering contributions to theoretical physics and as a leading advocate of string theory, confirmed that the James Webb Telescope has detected something truly extraordinary. 6 enormous, fully formed galaxies that appeared to have come into existence shockingly early in the cosmic timeline, far earlier than what any current scientific theory can comfortably explain. These galaxies are not only massive in scale, they are also more luminous, structured, and developed than even our own Milky Way galaxy. Their sheer size and maturity raise profound questions. The most baffling detail? These galaxies appear to have formed just 200 to 700 million years after the Big Bang, a time when, according to established scientific models, the universe was still in its chaotic infancy. This revelation has sparked confusion, fascination, and controversy in equal measure within the global scientific community. According to long-held beliefs, the universe after the Big Bang was essentially a dense, hot soup of particles. It took hundreds of thousands of years for even the first atoms to form. After that, it took hundreds of millions of additional years before stars and galaxies began to emerge from the darkness. So how, then, can these vast, complex galactic structures already exist so soon after the beginning of time? This mystery has given rise to an intense debate among astrophysicists and cosmologists. The scientific community has even given these galaxies a dramatic nickname: universe breakers. Why? Because if their age and size are confirmed, these galaxies shatter existing theories about how galaxies form and evolve and could force us to rewrite the entire narrative of the early universe. In other words, something doesn't fit. Our current understanding may be incomplete, or even fundamentally flawed. Dr. Kaku, however, isn't surprised by this development. Known for his openness to bold, paradigm-shifting ideas, he embraces these findings as part of the natural progression of science. In contrast to some more cautious or conservative thinkers, Dr. Kaku argues that science must evolve, especially when confronted with undeniable, experimental evidence that contradicts the status quo. He has long asserted that many major theories throughout history managed to survive far longer than they deserved, not because they were right, but because of the influence and prestige of the scientists behind them. Scientific dogma, he reminds us, is not uncommon. But it is evidence, not authority, that drives progress. The experimentalists, he says, are the ones who keep the theorists honest. That's precisely why the data from the James Webb Space Telescope is so important. It's not speculation, it's direct observation, and that means the scientific community must reckon with what it's seeing. In fact, this kind of scientific disruption has happened before. Many of today's fundamental truths were once considered heresies. People once believed Earth was the center of the universe. They believed the stars were fixed in the heavens. Only through observation, experimentation, and open-mindedness did science progress. Now, history may be repeating itself. These 6 massive galaxies might just be the beginning. If they are what they seem to be, they could point to a deeper, more complex story about the origin of the cosmos, a story that goes beyond the current Big Bang model, beyond existing galaxy formation theories, and perhaps into an entirely new frontier of understanding. To understand why these findings are so disruptive, we need to take a closer look at the theories they're challenging. The Big Bang theory, which has been the dominant explanation for the origin of the universe for nearly a century, was first introduced in 1927. It was based on the observation that galaxies are moving away from one another, a phenomenon known as the expansion of the universe. This expansion was quantified by what we now call Hubbles Law. It suggested that, if we reverse time, all matter in the universe once existed in a single, extremely hot and dense point, the so-called cosmic singularity, before expanding outward in what we now refer to as the Big Bang. Over the years, this theory has been supported by various forms of evidence including the cosmic microwave background radiation, the abundance of light elements, and most notably, the redshift observed in the light from distant galaxies. Redshift is similar to the Doppler effect with sound. Just as a siren sounds higher-pitched when it approaches you and lower-pitched as it moves away, light from objects moving away from us shifts toward the red end of the spectrum. This shift allows scientists to measure the speed and distance of celestial objects. However, redshift measurements are incredibly delicate. Even small errors or assumptions in calculating them could drastically alter our understanding of when and how galaxies form. That's why some scientists are urging caution. They suggest that perhaps what we're seeing are redshift miscalculations or distortions. Maybe these galaxies aren't as old or as massive as they appear. But Dr. Kaku and others are not convinced this is a mistake. He reminds us that major breakthroughs in science often begin with anomalies, results that don't fit the mold, that challenge assumptions, and that invite us to dig deeper. Just like early astronomers once believed that Earth was at the center of the universe, many scientific ideas seemed absolute until technology and observation proved otherwise. The James Webb Space Telescope was expected to validate the Big Bang model by observing the first galaxies forming gradually over billions of years. Instead, it found something entirely different: massive galaxies already in existence when the universe was still in its infancy. This could mean one of two things. Either our timeline for the formation of galaxies is completely wrong, or the universe itself might be far older than we think. Dr. Kaku sees this moment as an exciting turning point, a chance to rethink the universe not with fear, but with curiosity and a commitment to truth. After all, that is the essence of science. Not to cling to old ideas, but to follow the evidence, wherever it may lead. This isn't just about galaxies. It's about the nature of the cosmos, the story of our origin, and the future of scientific discovery. As researchers continue to analyze this data, one thing is certain: we are entering a new era of astronomy. Whether these discoveries confirm our deepest suspicions or lead us to rewrite the textbooks, they prove one important fact: the universe is still full of mysteries, and science must always be ready to explore them with an open mind. Thank you for being part of this journey. If this video sparked your curiosity, please give it a like, share it with fellow space enthusiasts, and subscribe to the channel for more exciting explorations of the cosmos. Drop your thoughts and questions in the comments. We'd love to hear what you think about this potential paradigm shift in our understanding of the universe. We'll see you in the next video.